Section 2.5 is on function notation. In part A, we're looking at domain and range. First, the definition says that a relation is a correspondence between a first set of values called the domain and a second set of values of dependent values called the range. So to highlight that or emphasize it, the independent values are in the domain and the dependent values are in the range. Okay. Now, there are a couple different ways to represent your information. We're representing these all as data instead of words right here. But our independent values in these cases are our X type values. So we'll make a note of that as well. Those are the X's, and the dependent values are the Y type values. So there are going to be a couple different ways of listing this as well. So I have, my goal right here is to find the domain and range in inequality and interval notations. I'm going to be writing both my domain and my ranges twice. So I'm going to make a little chart for domain and range. And we're going to have the two notations, the inequality notation and then the interval notation. Okay. All right. I'm thinking to myself for a moment that there's not an inequality notation for this one. That's going to happen for these ones down here, for the ones that are continuous. So I might not actually use both of those for the first one. I'm just reading my directions first. Okay. And by the way, just the reason for this is when you do some homework, you're going to notice that my math lab uses the inequality notation. So you will be seeing the inequality notation. However, if you take future classes, that's going to change. And so we need to be familiar with the interval notation. So future classes are going to be using the interval notation. So we're going to be working with both of them for sure. We want to practice both of them. You actually do see inequality notation sometimes in the sciences as well, so that it does have its own reason. But math, future classes, if you do go on in math and go up to 139, for example, or anything in calculus for sure, you're going to be using the interval notation a lot more. It's more handy in those contexts. So that's part of the reason that we'll be having both of those where it is appropriate, which is in part D's, E's, and F's. All right, first of all, domain. Okay, this one is actually going to get a notation that's not called out as one of these. It's going to be set notation. And it's getting set notation because it is discrete. And what discrete means is that your data is not connected. It's just a list of data values where you don't have a continuous set of data values. The opposite of discrete is continuous or finite number of pairs. All right, so I will use these squiggly brackets for that kind of data. You can see the squiggly brackets right here. And use that squiggly brackets to list my domain and range. So my domain, squiggle, bracket, and then I want to do it in order, independent values only. So I look through my X's for domains, independent only, and just get the smallest one. So negative 2, 2, 0, 3. Looks like it's going to be in the order negative 2, 0, 2, 3, squiggly bracket. That's my domain. Okay. Range, squiggly bracket. 3, 4, negative 1, negative 1. So the smallest one is negative 1. Then I have 3. Then I have 4. Okay. So just I'm going to put my notes over here, right here. I want to note about that range. There are only 3 things in the range set, despite the fact that there were 4 pairs up here. And that's because you have your overlap. You have 2 things that went to negative 1. It's only in the range 1 time. So you want no repeated values. Okay. All right, we'll do it again for the next one. This is also going to use set notation because you have a discrete or finite number of ordered pairs. There's just 1, 2, 3, 4 of them. So for my domain, squiggle, the smallest value is negative 3, and the next value is 2, the next value is 3. I use 2 twice, but I only have to list it in my domain once. The range, 0, 6, 12, and 18. All 4 values are in that range. Squiggly brackets for our set notation, commas in between them. Okay. When I get to part C, it's a picture of the same type of things as A and B. A picture of discrete data because there's no connections. So I use set notation for my domain and range. Okay, X values. So those are -5 being the smallest, -2, 0, 1, I'm going to go down the next line, and 4. Those should all fit in one line, they just don't fit in my space, so I put those 4 elements in the domain. For range, this is a set where the only Y value is 3, so it's going to contain just that one element. 3, that's the range, that's the only number in the range. All right. Okay, so I'm getting my highlighter out real quick. Just want to emphasize the fact that those 3 up there are that discrete type. These 3 in the next section are all going to be continuous. So they will operate the same as each other, but different from the discrete type. They're connected. They're not just a finite number of dots. You can't just dot, dot, dot and move your pen. You have to connect through them. You couldn't make a list of all the values because even right here, you're at 0, then you're at 0.1, then 0.2, then 0.2222, and you can't list every number. So that's where the inequality and the intervals come into play. Those 2 titles really were for the continuous. Most of our data and graphs and functions are continuous, so we see those names. I should edit that to say set, inequality, or interval notation, since set was the other option over there. All right, so those are for the continuous. Okay, so off to my side, I'm going to label these 3 as continuous or connected. So because the graphs are continuous or connected, they're going to look different from the ones that were discrete. Okay. So domain. Okay, the smallest x value is -4. The largest x value is 4. So in inequality notation, that would look like x less than, that is filled in. So or equal to x less than or equal to 4. Right, so another note to make is that if you are filled in, if you have a solid point, means equal bar. And so you're getting the less than or equal to symbol with that equal bar right there. All right. Otherwise, it would just be a less than symbol without the equal bar if it had an open circle. All right, so that's the domain in inequality notation. Now we're going to do the same domain in interval notation. So interval notation does the same job, it's just a little shorter. So you know your domain is about your x's. You don't have to write the x. You can just say the smallest number is -4, comma, the largest number is 4, and then you use brackets for the equal bar. If there wasn't an equal bar, you would use parentheses. So I'll make a note, less than or equal to, bracket, less than, parenthesis. Okay, so I'll even write bracket there so we know what I was drawing. That's a bracket versus a parenthesis. Same thing for the graders, of course, but you won't see those in domain and range. Oops, I drew on my table. Now I've got our range, so we're going to go with the smallest y value to the highest y value. So my smallest y value, remember you're not looking at your endpoints necessarily, they happen to be the leftmost and the rightmost. But that's domain and range, is leftmost and rightmost. What you're looking at for range is lowest and highest. So our lowest is going to be -2 and our highest is going to be 4. So we're going to have from -2 is less than or equal to y, because its range is less than or equal to 4. you know it's range. So in interval notation, you don't have to write the y. You do bracket -2, 4. Two notations for the same thing there. It is important to note that the variable switches. Domain it's x, range it's y. In an interval notation, you can't tell, if you didn't know you're talking about domain or range, which one was which. So you need to have them labeled to make sure you know which of these is the domain and which is the range. Okay. Let's get our domain and our range for parts E and F. E, the domain, the smallest x value, leftmost is, looks like -4, and the highest is 5. So my domain is going to be -4 less than or equal to x less than or equal to 5. And an interval notation, that's -4 bracket, 5 bracket. Then for the range, I want the lowest and the highest. The lowest looks like it's at -4, and the highest looks like it's at +4. So -4 is less than or equal to y is less than or equal to +4, or the interval bracket, comma, from -4 to 4 bracket. Part F, the last one. Okay. Without having these dots here, these big solid dots that end the graph, this graph is assumed to continue on. Because it continues on all the way to the left, all the way to the right, it doesn't have a lowest value, it doesn't have a highest value. So in interval notation, it would go from -infinity to +infinity. There is not an inequality way to write that. So I can write it as -infinity to infinity as an interval. The other way to write it is actually in set notation. And it's in words, I'll write it first, it would be all real numbers. Sometimes you'll just see it written out in words. In set notation, it's actually a capital R with 2 bars. So you can have one of those 3 choices. All real numbers written out in words, capital R with double bars, or -infinity to infinity. In upper level mathematics, you're going to see the interval -infinity to infinity. Okay. We can also write it out in words or write that capital R bar, which you also see in upper level mathematics, the set notation for this. That's the domain of this one. The range of this one, well, this one also goes all the way down and all the way up. So the range is the same thing. All real numbers, which is that capital R double bar, or an interval notation, -infinity to +infinity. I'm going to throw in one more graph here at the bottom, because I really think we should look at a picture that has an infinity, but doesn't have it in both cases. So if I look at, that's just my x-axis, y-axis. If I look at a graph that looks like this, where that's my top, and that's at, say, 2. Okay, in this one, the domain would be all real numbers. I'm only going to write that once, because you do go all the way left and all the way right. But the range, so there are 2 ways to write this range. So we will be able to write this range both in inequality and interval notation. In inequality notation, the range is all values that are less than whatever that top one was. I called it 2 for this little sketch I drew. So this would be y less than or equal to 2. Inequality notation. In interval notation, what it would be is you get all the negatives, and then 2 is your highest. So you go down to -infinity, comma, you get up to 2, bracket. I should mention those brackets. Okay, we talked about brackets up here being included, and we put firm, hard brackets around the boundaries here. I stuck parentheses around these infinities. Did you notice that before? These had parentheses around them. Parentheses signify that a value is not included, and I can't include infinity because it's not actually a number, it's an idea. I can't reach it. So infinity, even if you're using a bracket and a number, infinity can never have a bracket. So just a note, infinity cannot be included. So it's got parentheses only.